Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone. Today we are learn about chapter 9, carbonyl compounds. There are 4 subtopics in this chapter. The first one is introduction, the second one nomenclature, preparation, and the last one you will learn about chemical properties of carbonyl compounds. Do you know that the carbonyl compounds are present in all types of organic compounds? This is an example of the compounds that contains carbonyl group such as vanilla beans, cinnamons, and bitter almonds. Structure of aldehyde and ketones are also responsible for the smell and taste in aromatic compounds found in nature. For example, you can smell the odor of roses because it contains the carbonyl group. This is another example of the compounds that contains carbonyl group. But do you know what is carbonyl group to begin with? If you don't, let us help you out. In the first subtopic, you will learn about the general formula of aldehyde and ketones. The functional group of carbonyl compounds is a carbonyl functional group. The general formula is CnH2nO. And the class of compounds that contains the functional group of carbonyl is aldehyde and ketone, which is an isomeric. There are polar compounds because carbon and oxygen has a different electronegativity. But between aldehyde and ketones, aldehyde is more reactive than ketones towards nucleophilic addition reaction. As I mentioned just now, there are two classes of compounds that contains the functional group of carbonyl. The first one is aldehyde, another one is ketone. This is the general formula for aldehyde and this is the general formula for ketones. As you can see here, in an aldehyde, the carbonyl functional groups is attached to hydrogen and always found at the end of the chain. But in ketones, the carbonyl functional groups attach or bonded to two carbons atom. Either it is an alkyl or aryl group. In the second subtopic, you will learn about how to draw structure and name the aldehyde and ketones, which is the parent chain is less or equal to 10 carbon, according to the IUPAC nomenclature. For the nomenclature of aldehyde, the first one, aldehyde, is named by substituting the letter E of the corresponding alkene with al. The second one, for the basic name or the parent name, depends on the longest chain, contains carbonyl functional group. And then, the chain is numbered by starting with carbonyl functional group as carbon number 1. There are a couple of common names which are acceptable as IUPAC name. They are shown in the example here. For example, for the IUPAC name of the first structure is methanol and the common name is formaldehyde. And then we have ethanol. The common name is acetaldehyde. The last structure, the IUPAC name is phenylmethanol, but the common name is benzaldehyde. Let's discuss how to naming an aldehyde. Please refer to the first example. Firstly, you need to find the parent name. As you can see here, we have two functional groups. The first one is carbon-carbon double bond and the other one is carbonyl functional group. You learned before this, carbonyl functional group has high priority to be a parent. So that's why the chain is numbered by starting with carbonyl functional group as carbon number 1. If you notice here, we have carbonyl functional group is bonded to hydrogen. Means this is an aldehyde. The parent should become butanal. But at carbon number 3, we have carbon-carbon double bond as a substituent. So this structure, we have 3-butanal. We change the alphabet A with E that refer to the carbon-carbon double bond as a substituent, which is at carbon number 3. Example 2. For this structure, carbonyl functional group also has high priority to be parent compared to hydroxyl group. So, carbon of carbonyl will numbered as carbon number 1. And because the longest chain contain 4 carbon, so the parent should become butanal. Okay, then at carbon number 2, we have ethyl, and at carbon number 3, we have hydroxyl as a substituent. So the name of this structure will become 2-ethyl-3-hydroxybutanal according to alphabetical order, which is alphabet E come first compared to alphabet H. For the next example, we have the structure of aliphatic aldehyde containing a ring. So these structures are named by adding the suffix carbaldehyde to the name of the corresponding hydrocarbon. That's why the name of this structure is cyclohexane carbaldehyde. For the example 4, the parent name is ethanol. Okay, because we have 2 carbon chain and the benzene ring will become a substituent, which is attached at carbon number 2. So the name of this structure is 2-phenylethanol. Let's discuss how to naming a ketone. Firstly, ketone is named by substituting letter E of the corresponding alkane with -one. And then, the basic name or parent name of ketone depends on the longest chain with carbonyl group. Chain is numbered in the way that gives carbonyl-carbon atom the lower possible number. This number is used to design its position. And then, common functional group name for ketone separately naming the 2 group attached to carbonyl group and adding the word ketone as a separate word. Let's discuss for an example to make you have a better understanding. There are several simple carbonyl containing compounds which have a common name which are retained by IUPAC. You can refer in this table. For example, first structure, the IUPAC name is propanol, but the common name is acetone. In this slide, also, we have a structure of ketone that use a different IUPAC name and common name. To make you have a better understanding, everyone, here's some example how to name the ketone. Example 5. In this example, we have 5 carbon as the longest carbon chain that containing the carbonyl functional group. But the question here is, which carbon will become a carbon number 1? Either this carbon or this carbon is counted as carbon number 1. So, carbon of functional group or carbonyl functional group should have a lower possible number. So, that's why we count this carbon as a carbon number 1 and the name of this structure will become pentane 2-one or 2-pentanone. So, the number 2 here is indicate the position of carbonyl functional group which is at carbon number 2. Example 6. In this example, the parent should be propan-2-on or 2-propanone because we have carbonyl functional group at the carbon number 2 and this carbon is assigned as a carbon number 1 to give a lower number for substituent. So that's why the name of this structure will become 1-cyclopentyl propane-2-on or 1-cyclopentyl 2-propanone. In example 7, we have cyclic structure of a ketone. In this case, you must give the carbonyl group priority when you deciding which carbon to begin numbering. So, automatically, carbon of functional group is count as a carbon number 1. So, the parent name should be cyclohexanone because we have 6 carbon in a ring. Then, we have a methyl and isopropyl as a substituent. So, we count it in order of clockwise according to alphabetical order. I is come first before M. So, isopropyl should get a lower number as a substituent. So, that's why this structure will become 3-isopropyl 5-methyl cyclohexanone. Example 8. So in this example, the longest carbon chain is 3 carbon and carbonyl functional group will become a carbon number 1. So the parent name should be propan-1-on or 1-propanone. Then, at carbon number 1, also we have a benzene ring as a substituent. So, the name of this structure is 1-phenyl-propan-1-on or 1-phenyl-1-propanone. Example 9. For this example, the longest carbon chain is 6 carbon, which is carbonyl functional group is located at carbon number 3 and we count this carbon as a carbon number 1 to get lower number for functional group. Then at carbon number 4, we have carbon-carbon double bond as a substituent. So that's why the name of this structure will become hex 4-in-3-on, which is number 4 and alphabet E here indicate the position of carbon-carbon double bond as a substituent and number 3 here indicate the position of functional group which is at carbon number 3. Example 10. In this example, we have 5 carbon counted as the longest carbon chain containing the carbonyl functional group. In this case, we have 2 carbonyl functional group which is attached at carbon number 2 and carbon number 4. So, both carbonyl require a location number and the ending dione is added to the end of the parent chain. So, that's why the parent name will become pentane 2,4-dione. And then next, at carbon number 1 and carbon number 5, we have 2 identical substituent which is bromine and we need to add prefix di in the name. So this structure will become 1,5-dibromopentane 2,4-dione. For the last example, we have cyclic structure of ketone. So remember, we must give carbonyl group priority when deciding which carbon to begin numbering. So, we count it in order of clockwise to get lower number for functional group. Similar to the previous example, we need to indicate both position of carbonyl functional group and added dione to the end of the parent chain. So the parent for this structure will become cyclohexane 1,3-dione. And then at carbon number 5, we have methyl as a substituent. So the full name for this structure will become 5-methyl cyclohexane 1,3-dione. For an exercise, please draw all structural formula for compounds which molecular formula is C5H10O and give the IUPAC name. So the hint is there are 7 possible structures that have the same molecular formula which is C5H10O. Maybe you can draw with a simple structure of aldehyde and ketone. So this is the answer. There are 7 possible structures starting with pentanal until 3-methyl-2-butanol.
Chapter 9.3a Preparation of Carbonyl Compound. Preparation of carbonyl compound can be produced through 3 reactions, which is first, ozonolysis of alkene, second, Friedel-Crafts acylation, and the third one is oxidation of alcohol. Ozonolysis of alkene will produce aldehyde or ketone or both. The general reaction is alkene will react with ozone followed by zinc and water to produce ketone and aldehyde based on the structure of alkene. This part you already learned in chapter 5 K1. These are the example of ozonolysis of alkene. As you look at the second example, the second part of ozonolysis can be substituted with dimethyl sulfide instead of zinc and water. Friedel-Crafts acylation. Friedel-Crafts acylation can be used to prepare aromatic ketones. Benzene will react with acyl chloride or acid chloride with the presence of Lewis acid, example as AlCl3, to produce aromatic ketone. This part you already learned in chapter 6.3a. Preparation of aldehyde and ketone can be made through oxidation of alcohol. For oxidation of primary alcohol, it will use mild oxidizing agent to produce aldehyde. For secondary alcohol, it will use either mild or strong oxidizing agent to produce ketone. This part you already learned in chapter 8.4b. There is 2 types of oxidizing agent, which is PCC, pyridinium chlorochromate in dichloromethane solution, which is mild oxidizing agent, and acidified potassium permanganate solution heated, acidified potassium dichromate solution heated, and chromic acid as the strong oxidizing agent. Chapter 9.4a, Chemical Properties of Carbonyl Compounds. For chemical properties of carbonyl compounds, there were 5 parts of it. The first one is nucleophilic addition, which involve in 5 nucleophilic addition. The second one is reduction to alcohol by using 3 reducing agent. The third one is condensation with ammonia derivative to produce 5 ammonia derivative. The fourth one is oxidation using strong oxidizing agent, and iodoform test to identify the methyl carbonyl group. Before we look further on nucleophilic addition reaction, I will explain to you why carbonyl is susceptible to nucleophilic addition. Carbonyl is carbon double bonded to oxygen. Oxygen is more electronegative than carbon. So, electron density will drawn more to oxygen, making carbon is deficient in electrons. So it is called as electrophilic site. Carbon will be the site for nucleophilic attack. When carbonyl carbon is attacked by nucleophile, the carbonyl pi bond is broken and a tetrahedral intermediate is formed. So the hybridization of carbonyl sp2 will changes to sp3. The double bond will break down and form 4 single bonds. 5 parts of nucleophilic addition. The first one is addition of hydrogen cyanide. The second one is addition of water. The third one is addition of alcohol. The fourth one is addition of sodium bisulfite. And the last one is addition of Grignard reagent. Addition of hydrogen cyanide. Carbonyl compound, which is aldehyde or ketone, should be react with HCN. So because of its toxicity, HCN will be prepared through in situ preparation, which is the mixture of potassium cyanide or sodium cyanide with sulfuric acid or hydrochloric acid. The product is cyanohydrin. Please note that this is addition reaction, so the carbon double bonded oxygen will be broken down to carbon single bonds. Addition of water. Carbonyl compound, which is aldehyde and ketone, will react with acidified water to produce hydrate. Hydrate is geminal diols. Geminal diols means that 2 hydroxyl group will be bonded to the same carbon. Addition of alcohol. For addition of alcohol, aldehyde and ketone will give different kind of product. For aldehyde that react with alcohol with the presence of acid catalyst will produce hemiacetal. Hemiacetal is a compound that have carbon attached to alkyl group, hydrogen, hydroxyl, and alkoxy group. Hemiacetal will react with alcohol with the presence of acid to produce acetal. Acetal is a compound that have alkyl group, hydrogen, and 2 alkoxy group attached to it. ketone. Ketone that react with alcohol with the presence of acid will produce hemiketal. Hemiketal is a compound that have two alkyl groups, one hydroxyl and one alkoxy group. The difference between hemiketal and hemiacetal is hemiacetal have one alkyl group and one hydrogen group, but for hemiketal it have two alkyl group attached to the carbon. Hemiketal can further react with alcohol with the presence of acid to produce ketal. Ketal is a compound that have two alkyl group and two alkoxy group attached to it. Addition of sodium bisulfite. Carbonyl compound, aldehyde or ketone will react with sodium bisulfite to produce bisulfate salt. Hydrogen in sodium bisulfite will attach to oxygen to form hydroxyl, and sulfite will attach to carbon to form bisulfate salt. The uses of the reaction is for purification of aldehyde or ketone from other non-soluble organic compounds. Addition of Grignard reagent. Reaction Grignard reagent with methanol followed by hydrolysis will produce primary alcohol. Reaction between Grignard reagent and other aldehyde other than methanol followed by hydrolysis will produce secondary alcohol. And reaction of Grignard reagent with ketone followed by hydrolysis will produce tertiary alcohol. Aqueous acid or diluted acid will be used in hydrolysis process. For this part, you already learned in chapter haloalkene. That's all for this video. For other chemical properties of carbonyl compound, you have to watch for next video. Thank you.
Okay, everyone. So for the next chemical properties of carbonyl, so we want to discuss reduction of carbonyl to form alcohol by using three different reducing agents. The first one, we use lithium aluminum hydride followed by hydrolysis, and then we use sodium borohydride in methanol or ethanol, and lastly we use catalytic hydrogenation. Okay everyone, here we have one structure which is contain two functional group, which is carbon-carbon double bond and carbonyl functional group. So when the compound undergo reduction reaction by using lithium aluminum hydride followed by hydrolysis, so carbonyl functional group will reduce to form an alcohol, but the carbon-carbon double bond is remain. So same situation when we use sodium borohydride in methanol. So carbonyl functional group reduce to alcohol, okay, then carbon-carbon double bond remain, okay, but when we use catalytic hydrogenation, so the carbonyl functional group reduce to form an alcohol, and reaction also occur at carbon-carbon double bond, which is it will become a single bond. So keep in mind, when a compound contains both carbonyl functional group and carbon-carbon double bond, effective reduction of one functional group by proper choice of reducing agent. Okay, next, chemical properties of carbonyl functional group is condensation. So condensation process is one of addition reaction followed by dehydration reaction. In this process, smaller molecules such as water, ammonia, and hydrochloric acid will be eliminated. In this reaction, ammonia and ammonia derivative will act as nucleophile. So ammonia derivative is one of the hydrogen of ammonia will be substituted by another group. Okay, for example, we have R group, hydroxy group, or amino group. Okay. condensation reaction involve addition reaction, which is two molecule carbonyl compound and ammonia derivative combines to form a larger molecule. So it will form carbonyl amine, which is unstable intermediate. Next step, the elimination of water or small molecule occur and it will form amine group. Okay, so you can see here in amine group, carbon will form double bond with nitrogen. Okay everyone, so this is an example of condensation with ammonia derivative. Okay, so here we have carbonyl functional group or carbonyl compound react with 2,4-dinitrophenylhydrazine, or we call it as Brady's reagent. So what happened here, we eliminate a smaller molecule. In this case, we eliminate water. So oxygen here and 2 hydrogen here. So it will form 2,4-dinitrophenylhydrazine. Okay, so we will eliminate water and carbon and nitrogen will combine to form phenylhydrazine. So you can see phenylhydrazine as a yellow or orange precipitate. Okay, so this is an example of ammonia derivative and the product form when it react with carbonyl compound. For example, we have a primary amine, so it will form imine as a product. Hydrazine, okay, it will form hydrazine. Hydroxyl amine, it will form oxime. Okay, next we have phenylhydrazine, okay, from phenylhydrazine, and then semi-carbazide, when it react with carbonyl compounds, it will form semi-carbazine. Okay, so carbonyl react with hydrazine or phenylhydrazine to form yellow or orange precipitate. So for further reaction, you will learn about this in the next subtopic. Okay, so the next reaction is oxidation. There are several oxidizing agents that we can use. For example, strong oxidizing agent. Okay, here we have hot acidified potassium permanganate, okay, hot acidified potassium dichromate, and chromic acid. Okay, but all of these strong oxidizing agents can't be used as differentiation tests to differentiate between aldehyde and ketone. Another oxidizing agent is Tollens reagent, okay, Fehling and Schiff reagent. So all of these can be used to differentiate between aldehyde and ketones. Okay everyone, if you have an aldehyde as a reactant, okay, and then we use strong oxidizing agent, so aldehyde will undergo oxidation to form carboxylic acid. But if we use mild oxidizing agent, for example, Tollens, Schiff, Fehling, or Benedict solution, okay, so it will form carboxylate ion. Okay, but if we have a ketone, so ketone cannot undergo oxidation or resistance to oxidation. Why? Because they do not have hydrogen attached to the carbonyl carbon atom. Okay everyone, so this is general equation for the reaction of oxidation and aldehyde. Okay, so reactant here we use aldehyde. Okay, reagent we use hot acidified potassium permanganate, or you also can use hot acidified potassium dichromate or hot acidified sodium dichromate. Okay, so the product here is carboxylic acid. So means when you have aldehyde as a reactant and it will undergo oxidation reaction by using strong oxidizing agent, it will form highly oxidized compound, which is carboxylic acid. Okay everyone, so the next reaction is iodoform test. So iodoform test is one of the tests that we use to identify methyl carbonyl group. Okay, methyl carbonyl group, here we have a methyl that attached to the carbonyl functional group. So the reagent that we use in iodoform test is excess iodine in base or sodium hydroxide. So observation or the product you can observe is light yellow precipitate is formed. Okay everyone, so this is general reaction, okay, which is methyl carbonyl, okay, react with excess iodine in sodium hydroxide, so it will form carboxylate ion and triiodomethane or iodoform. Okay, this is an example. Okay, example we have ethanol react with iodoform reagent. So it will form carboxylate ion and triiodomethane, which is the observation. You can see light yellow precipitate. Okay everyone, for an exercise, which structure show the formation of yellow precipitate with excess iodine in sodium hydroxide? So excess iodine in sodium hydroxide is iodoform reagent. Okay, so to know which structure show the formation of yellow precipitates means you need to find methyl carbonyl in each structure. Here the answer, only structure 1, 3 and 5 will react with excess iodine in sodium hydroxide or react with iodoform reagent because all of these structure contain methyl carbonyl.